Hi everyone, thank you for joining my video. Today we're going to do a question from Cambridge entrance paper. I think it was step 1 or step 2, I can't remember. And then the question says that which of the following statements are true or false, and we have to justify, we have to prove why it is true or find a counterexample, right? So if you like to pause the video here and try part I, then we will go over it together. Right, so let's have a look at it. A ln b is equal to b to the power of ln a. Now, if we apply ln to both sides, can we do that? Yes, we can do that because a and b are positive, right? Okay, so, and then if we use the power rule, we have ln b times ln a on the left hand side, on the right hand side ln a times ln b. Well, clearly this is true for any a and b, isn't it? Because it's like saying 2 is equal to 2, right? So the first claim we agree with, that's true. And the second part, given that the theta is real, is this equality, would this equality hold for all real theta? So if you'd like to pause the video here and try question 2, then we could go over it together. Right, so it's quite obvious that it is not true for all real, because let theta be 0 degrees. Left hand side we have cos sine of 0. That's equal to cos, well, sine of 0 is 0 and cos 0 is 1. That is left hand side, and the right hand side will equal to sine cosine of 0, which is equal to sine of 1, because cosine of 0 is 1. That is not equal to 1. Okay, so we've proved it, and that's, in other words, the second is not true, it's false. Yeah. And the third, we're looking for a polynomial such that when we subtract cos x from it, it will always be less than a very small number, and the angle is theta. Now, if it was not restricted by polynomials, we want ax to the n, where n is a positive number, right? And of course, it is a whole number. We're looking for x squared, x cubed, x to the 4, and so on. And n is a finite number, so it is impossible, actually. But if we had, for example, just a rough guess, if theta was equal to, if we were allowed to have, for example, theta plus 10 to the 6, I think this would solve the problem. Because what we are doing here is that we have 1 over theta graph, and we're shifting it to by 1,000,000. So where it cuts the axis here would be, that would be 1. So if we look at it, in fact, why don't we look at Desmos? Desmos graphing. So let's have a look at it. So if we had 1 over x plus 10 to the 6, we said, right? 1, 2, 3, 4, 5, 6. So let's see where it cuts the x-axis. Where does it cut the x-axis? Yeah, so that exactly cuts there, doesn't it? So, right, 1 times 10 to the minus 6. And if we plot, if we do that minus cosine of x, did I do something meaningless? Let's put the modulus in. So let's have a look at part 3. It says that is there a polynomial e of theta minus cos theta will always give you less than something? Well, no, let's not look at it. So the answer would be, this would be false as well. And lastly, x to the 4, we have x to the 4 plus 3 plus x to the minus 4 greater than or equal to 5. Well, if we let y to be x to the 4, that means we have y plus 3 plus 1 over y greater than or equal to 5. So that implies y squared plus 3y plus 1 greater than or equal to 5y. We can multiply by y without worrying about the inequality sign, because y is a positive number. Right, so that means we have y squared minus 2y plus 1 is greater than or equal to 0. Y minus 1 squared is greater than or equal to 0. Well, that's always true, isn't it? Because if y is 1, we get 0, fine. But anything else, you get something greater than 0. Yep. So the last one is true as well. I hope you liked it. I hope you found it interesting. Thank you for joining, and I look forward to seeing you in my future videos. Thank you.